After studying this module, you shall be able to know how organic reactions proceed, identify the different types of reaction mechanisms, analyze the difference between each type of mechanism.
Dear students, in the previous module you have become familiar about the various types of reactions, and these you were already aware, but it was a recap or review of that so that we can study the further organic chemistry with more comfort. That is, you shall be able to understand it in a more proper or simple manner. So, in this module we shall continue the study and we shall see how the reaction mechanism happens in these different types of reactions, and the types of reaction that we will be studying in this module are the substitution nucleophilic unimolecular mechanism, that is SN1, the substitution nucleophilic bimolecular mechanism, that is SN2, the substitution nucleophilic internal mechanism, that is SNI. Then we shall study about the aromatic nucleophilic substitution, that is SNAR, the substitution radical nucleophilic unimolecular, that is SRN1, the electrophilic aromatic substitution mechanism, that is EAS. Then we shall discuss the elimination mechanism, where we will study both the unimolecular and bimolecular mechanisms, as well as the conjugate base elimination mechanism, that is even CB, and we shall also study the elimination internal mechanism, that is EI. After that we shall see how the mechanism of free radical reactions takes place and how the concerted mechanism takes place with some examples. Now, before we go into the details of the reaction mechanism, it is very important for you to be familiar with some terms. So, we shall be encountering what are substrates, that is they are the organic compounds on which the attacking reagent will be attacking, and that will be undergoing a change to give you the product. So, you should be able to identify that in a given reaction which is the substrate and which is the reagent, and then reagent in the appropriate conditions it will generate either the nucleophile or the electrophile or the free radical, and you should be able to identify what are these conditions, whether it will go into the heterolytic cleavage, then it will be formation of nucleophile and electrophile, and if it is the homolytic cleavage, then you will be having the generation of free radical. And then there are different solvent, temperature, other conditions where the same molecule can go into either the electrophile nucleophile generation type of cleavage, or you can have the free radicals. Like for example, if you consider the case of bromine, bromine under the photolytic conditions will give you the bromine free radical, but bromine in aqueous medium, the polar solvents, it will generate the Br plus. So, the same reagent in different conditions can give rise to different type of species. So, you should be able to identify that before looking at what type of reaction is going to happen. Then you should also be able to identify what is a leaving group, and when once you have identified the substrate, then what atom or group of atoms is getting replaced by some new atom or group or atom. So, the group or atom which is being knocked out or leaving from the molecule, the substrate molecule, that is what you should be able to identify. Furthermore, once you are doing the reactions, then in between the mechanism you shall be encountering the reaction intermediates, and these reaction intermediates, they are nothing but they are the temporary products or reactants, and generally either they are ions or free radicals. For example, you can encounter a carbocation or a carbanion or a free radical and so on. So, what are these reaction intermediates? You should be able to identify them in further better understanding of the mechanism. After this, you shall be able to know what are transition state, because not in every reaction you will find the well formed carbocations or carbanions as the intermediates, rather they will be transition state, which is an unstable intermediate molecular state, and that will be having unusual number of bonds or unstable geometry. Like for example, in case of SN2, when there is a backside attack, then in between there will be transition state formation, which will be 5-membered structure on carbon, which is unusual because carbon is otherwise tetravalent. So here this is unstable in between situation, and these are the ones which are referred to as the transition states. Then you should also be familiar and try to relate the knowledge of kinetics, that is, you should know what is the order of a reaction, what is the molecularity, and then you shall be able to better understand the kinetics, that is whether the reaction is proceeding via the unimolecular pathway or bimolecular or termolecular pathway. So with this background, let us try to study this module, and it will be again a review and help you in better understanding of the further modules. So dear students, let us now summarize what we have learned in this module. We have got an overview how to write the mechanism of some different types of reactions, and in this process we have seen how to write the various mechanisms when a reaction is taking different pathway. Like if we talk about the substitution reactions where the nucleophile is attacking, then it can be unimolecular, that is SN1, or bimolecular, that is SN2, or they can be internal mechanism SNI. Similarly, when we are having nucleophilic substitution in aromatic molecules, then it can take the course of SNAR, or we can have the benzene mechanism as well. Then we have also studied that how the substitution radical nucleophilic unimolecular reactions takes place, and we have also got the overall idea about the electrophilic aromatic substitution mechanism. Further, we have also seen how the elimination mechanism take place, which are further unimolecular, that is E1, bimolecular, that is E2, or conjugate base elimination mechanism, that is E1CB, or the elimination internal mechanism, that is EI. And then we have seen how the free radical mechanism can be listed and how the concerted mechanisms takes place.
We will now see what all is included in a reaction mechanism. It considers the following aspects: elementary processes, the actual process, bonds broken, number of steps involved, the position of all atoms, role of solvent molecules, the energy of the system, the reaction intermediate, activated complex and transition state, the reactants used, the function of a catalyst, all products formed and their amount, and the rate law. Let us learn about the various types of organic reaction mechanisms. Organic reactions proceed via various mechanisms. Some common mechanisms are substitution nucleophilic unimolecular SN1, substitution nucleophilic bimolecular SN2, substitution nucleophilic internal SNI, substitution nucleophilic aromatic SNAR, substitution radical nucleophilic unimolecular SRN1, electrophilic aromatic substitution EAS, unimolecular elimination E1, bimolecular elimination E2, conjugate base elimination E1CB, elimination internal EI, free radical and concerted mechanisms. We will start with substitution nucleophilic, that is SN1 reaction mechanism. SN1 is a unimolecular nucleophilic substitution reaction. Here 1 means that the rate of reaction is dependent on the concentration of one reactant. In an SN1 reaction, the rate determining step is the loss of the leaving group to form the intermediate carbocation. Let us understand SN1 reaction with the help of an example.
The reaction of tertiary butyl bromide with the water molecule under acidic conditions is a type of substitution nucleophilic unimolecular, that is SN1 reaction. SN1 reaction proceeds in two steps. Step 1 is formation of a carbocation. It is a slow step. Step 2 is capture of carbocation by a nucleophile. It is a fast step. The more stable the carbocation.
Now we come to substitution nucleophilic bimolecular or SN2 reaction. The term SN2 means that the rate of reaction is dependent on the concentration of two molecules. It is a one-step process. The departure of the leaving group occurs simultaneously with the backside attack by the nucleophile. Let us understand SN2 mechanism with an example. For example, the reaction of methyl bromide with hydroxide ion follows SN2 mechanism. The substrate is attacked by a nucleophile from backside and leaving group leaves simultaneously. A stable transition state is formed in this reaction. If the substrate has chiral carbon atom, that is, all the four groups on the carbon are different, then it is represented in wedge notation. In this representation, the group shown with bold line is above the plane and the group with dashed line is below the plane, while the remaining two substituents are in plane. Thus, the substrate has tetrahedral structure. However, the transition state looks like trigonal bipyramidal, but the product formed has tetrahedral structure similar to the substrate. Thus, after the departure of the leaving group, the product formed will have inverted configuration. Thus, SN2 reaction is a one-step process where two reacting species are involved in the slow rate-determining step. Substitution nucleophilic internal mechanism (SNI) is yet another mechanism by which some organic reactions proceed. It is similar to an SN1 reaction. However, in SNI, the nucleophile is a part of the reagent used in the reaction. For example, replacement of OH of alcohols by a chloro in the presence of thionyl chloride SOCl2 proceeds via SNI mechanism. It follows second order rate law. In aromatic nucleophilic substitution mechanism, a strong nucleophile replaces a leaving group. It can be through an addition-elimination, elimination-addition, or aryl cation mechanism. Let us understand an addition-elimination mechanism. Here, substitution takes place at ipso position. Presence of strong electron withdrawing group at ortho or para to the leaving group favors Addition-Elimination Mechanism. It uses one of the vacant pi star orbitals for bonding interaction with the nucleophile. This allows addition of nucleophile to the aromatic ring without displacing any substituent. Net substitution occurs in second step by elimination of leaving group. Example of reaction undergoing through addition-elimination mechanism is the reaction of para-nitrofluorobenzene with sodium methoxide. It is a two-step mechanism. The first step is a slow step. Aromaticity of the ring lost in this step. Nucleophile attacks aryl halide and bonds to the carbon that bears the halogen. The intermediate formed is stabilized via resonance. Presence of electron withdrawing group at ortho or para position provides extra stabilization, which can be clearly seen in the Meschenheimer complex formed. The second step is a fast step. Aromaticity of ring is restored in this step. Intermediate formed in first step loses halide. Another example of elimination-addition mechanism is the reaction of chlorobenzene with soda amide in liquid ammonia. In this reaction, chlorobenzene is converted to aniline via a benzyne intermediate. In an elimination-addition mechanism, the first step is elimination of proton ortho to the substituent present and formation of benzyne intermediate. Second step is attack of amide ion on the benzyne intermediate. The last step involves abstraction of proton from ammonia. The aromatic aryl cation SN1 mechanism is encountered with disonium salts as shown here. Now we will learn about substitution radical nucleophilic unimolecular reaction, that is SRN1. In organic chemistry, SRN1 is a type of substitution reaction in which a certain substituent on an aromatic compound is replaced by a nucleophile through an intermediary free radical species. An example of this reaction type is the Sandmeyer reaction, which involves synthesis of aryl halides from aryl disonium salts via SRN1 mechanism. Examples of reactions undergoing electrophilic aromatic substitution mechanism, that is EAS, are nitration, sulfonation, halogenation and Friedel-Crafts reactions. During nitration of benzene or substituted benzenes, the hydrogen atom of the ring is substituted by a nitro group. Here, nitronium ion acts as the electrophile. Now, we will learn about unimolecular elimination mechanism, E1. First step of a unimolecular elimination mechanism is the loss of leaving group and formation of a carbocation, which is a slow and rate determining step. The overall elimination is completed by rapid removal of proton from adjacent carbon by attack of a base, leading to formation of a double bond between the two carbon atoms. Here we can see the dehydrohalogenation of alkyl halide, which is an example of unimolecular elimination mechanism, that is E1. In the bimolecular elimination mechanism, E2, a base abstracts a proton from a carbon adjacent to the carbon attached to the leaving group. The electron pair left on the carbon force the leaving group to leave and create a double bond. All this occur simultaneously in this mechanism. Examples of bimolecular elimination mechanism E2 is the base-induced elimination of hydrogen halide from alkyl halide. In a conjugate base elimination mechanism E1CB, the CH bond breaks with formation of carbanion as intermediate. Formation of carbanion is fast and loss of leaving group is slow and rate limiting. As we studied earlier, the E1 mechanism requires formation of a primary carbocation, whereas here in the E1CB mechanism, the reaction proceeds via a carbanion intermediate. Now we come to elimination internal mechanism, that is EI, in which two vicinal substituents on an alkane framework leaves simultaneously in a single step to form an alkene in a syn elimination. Examples are eliminations involving the Burgess reagent, Hofmann elimination, the Cope elimination, and ester pyrolysis. Let us see the Cope reaction. The Cope reaction is an elimination reaction of the N-oxide of a tertiary amine to form an alkene and a hydroxyl amine. The reaction mechanism involves an intramolecular 5-membered cyclic transition state. In radical mechanism, homolytic bond cleavage takes place. The free radicals are involved in chain reaction, which leads to chain propagation. The final step, chain termination, involves combination of two radicals as shown in the figure. Concerted reaction mechanism occurs without any intermediate. The transition state involves bond breaking and bond formation. The concerted pericyclic reactions involve reorganization of electrons through cyclic transition structures. Diels-Alder reaction between diene and dienophile is an example of concerted cycloaddition reaction. Now we will finally summarize what all we learned in this module. We learned that mechanism for a reaction is a collection of elementary processes that explains how the overall reaction proceeds. We also learned the different types of mechanism via which an organic reaction may proceed. These are substitution nucleophilic unimolecular mechanism, SN1, substitution nucleophilic bimolecular mechanism, SN2, substitution nucleophilic internal mechanism, SNI, aromatic nucleophilic substitution mechanism, SNAR, substitution radical nucleophilic unimolecular, SRN1. Electrophilic Aromatic Substitution Mechanism, EAS. Unimolecular Elimination Mechanism, E1. Bimolecular Elimination Mechanism, E2. Conjugate Base Elimination Mechanism, E1CB. Elimination Internal Mechanism, EI. Free Radical Mechanism and Concerted Mechanism.